Hey everybody, welcome back to Making SpacePOM, our series how we produce our Pomeranian platformer. I'm Brian.
I'm Tanya.
I'm Peter.
And I'm Kieran.
Last time, we explored the origins of the SpacePOM project, how we fell prey to scope creep, and how we managed to turn things around to release a demo in 2018. After the demo's release, the next thing we did was to take a long break. Everyone moved on to other projects, and for the next few months, we did no work on SpacePOM at all. In hindsight, this was probably the best decision we'd made up to that point. Getting some distance from the demo version allowed us to see the game with fresh eyes, and the interlude also gave each of us a chance to improve our skills. When we came back, we were determined to do it right. Upon returning in January of 2019, the first and biggest decision we made was to start over from scratch instead of trying to forge ahead from where we left off. There were several compelling reasons to do this, the first being the massive quantity of technical issues the demo version suffered from. While there were many varied problems, a perfect example was the level background. Made of thousands of individual objects, one for each tile of the walls, the level background was incredibly slow to load and demanding to render. Making changes to the level layout was extremely time-consuming, as it might involve repositioning several hundred objects. We'd learned a lot since the level was originally built, so we hoped by scrapping it and beginning again, we could make a newer, better version. Starting over also allowed us to finally see our scope creep problem for what it was and address it. The very first new work we did when coming back to SpacePOM was to create a document on how we'd change our approach. At its core were three simple ideas: making a solid plan to start with, focusing on working efficiently, and building in self-reflection to keep the project on track.
That solid plan took the form of a game design document we started writing next. We decided to reevaluate each element of the game and determined a new vision for the project as a whole. We started with the basics: our target platform, the general size of the game, and the mechanics we wanted to include. After considering the alternatives, phones, consoles, and the web, it was pretty clear to us that the game's home really should be on PC. The team determined we should expand the game beyond the size of the demo. We ended up making it an order of magnitude larger. We also felt platforming and the single mini puzzle was not enough to make the game fun to play for the full runtime. So we added in several more types of interactions: new puzzle types, moving platforms, objects to inspect, and more narrative text to read. We had plenty of ideas on how to make the environment more hazardous, including collapsing platforms, mobile enemies, and laser turrets. Most of the new hazards did not make it into the game because we were concerned about overextending the scope again. When it came to updating the design, it only seemed logical that I take the lead for designing the levels, as I had done the level design for the demo, and the rest of the team started by working on creating new mini-puzzles. While the demo wasn't widely played, we felt that the reviews had strong feedback on gameplay and aspects that were missing or weak. The storyline, difficulty, and length of the game were some of the items that I identified as needing work. We made our new game design to specifically address each of these issues. The first change we made was to the mini puzzle. Instead of just keeping the puzzle we already had in the demo, we came up with at least 5 or 6 new puzzle ideas and ended up using 3 of them. We tried to integrate them into the new storyline of the game by centering the puzzles around connecting wires and shifting bits. In a computer, it felt like you were actually restoring the ship to be operational. The biggest change to SpacePOM was the storyline. While the demo did have some hints at a narrative, we really did not have a coherent one. We decided the task of developing a story would be best handled as a group effort, so 4 members of the team took the task of writing a new storyline from start to finish. This took us much longer than expected, but the game is better for it.
At the same time, the team's membership was also changing. We had a lot of team members that came and went after the demo project was wrapped up. Several people left the team, including Mark the creator and team leader. Some had conflicts with schedules, and some went back to school to study more on game design or animation. In the end, only 3 of us remained between the demo and the full game: Tanya, Peter, and me. We also had several new people join us to fill in the gaps left by the departing team members. As all of us are volunteers working on SpacePOM in our free time, there was a little difficulty finding people who would join the project for a substantial period. Several people expressed interest, but couldn't ultimately fit it in. After some searching, however, we found 3 new team members: Ding, Issa, and Kieran. Even though we had more people helping us, it was still a small team, and there was a lot we wanted to do. One thing we did to help us work more efficiently was split up into smaller working groups. Each focused on a particular aspect of the project, such as art, programming, narrative, or marketing. Some of us were in more than one group based on our different interests and skill sets. Specializing into these sub-teams made working in parallel much easier, and we managed to complete a lot more.
Perhaps the most significant workflow change we made when we returned to the project was adopting version control for file sharing and backup. Previously, we shared files over Google Drive, Dropbox, and email. This ad hoc system made integrating work from multiple people a challenge, and it was a major source of inefficiency and errors. Version control was the obvious solution to these problems. We decided to use Git, with Bitbucket hosting the repo in the cloud and SourceTree as an interface locally. None of the artists on the team had used Git before, so there was some initial confusion as everyone learned the workflow.
Starting off, it was hard to figure out, and there were multiple steps for submitting your work on the Unity files. I had to navigate complexities like making new branches, and making sure nothing went wrong with a pull request. It was all new to me, so there were even nights where I had to ask either Peter or Tanya to help me with my commits. To help out, Peter made a Google Doc with the steps, and eventually I can easily follow them when I want to upload my material to our project.
To address the level creation difficulties we were having in the demo, we decided we'd make a tool to ease that process. The basic idea was to separate the level design from the environment art, and to make sure that all of the gameplay elements were easily modifiable. We knew that making this tool would take extra time and add extra points of failure, but we hoped that the efficiency gain from easier level creation would more than make up for it. It worked out better even than we anticipated, as the finished tool, the level builder, allowed the entire team to get in on the level design process, make changes, and test new ideas quickly and simply. The original version of the level builder had two pieces, build mode and play mode. Build mode was for level creation. You could draw out rooms, place or arrange objects, and save or load level ideas. Play mode was for testing the level in progress. Pressing the play button would start a playable version of your build mode level, so you could figure out if your designs worked immediately.
As time went on, though, we ended up adding several more features to the level builder. First, the number of buildable objects grew from just 3, platforms, the player, and the level exit, to over a dozen, everything from hazards and collectibles to dialogue triggers and tutorial pop-ups. Many of these new objects required specific information to be set on each one, and we created a new logic mode to manage this data. Objects were given the ability to include parameters, some as simple as an isActive setting, others much more complex with lists of dialogue or connections to other objects. Using the logic mode, we could view and edit these parameters, then see their effects in play mode.
The last big change to the level builder was adding a camera mode. Before the mode was added, the camera followed the player, but it was at a fixed distance and could often hide important things out of frame. I decided to create a more controllable system, where we could specify what the camera should focus on in each area. We also allowed connections between camera nodes, which tell the camera to interpolate its position based on the player's proximity to each connected node.
While the level builder was being developed, I began figuring out the level designs with pen and paper. I started by using post-its to determine the types of spaces we needed, then drafted the layout for each level on graph paper. After that, I started grayboxing with the level builder created by Peter to lay out the space in Unity. Grayboxing is a flexible stage of the level design process that helps you determine if a level has a good feel to it as you navigate through the space.
We had a basic idea of the ship's layout thanks to Tanya's rough drafts, but we needed to flesh out the small details, such as hazards and other obstacles. The team started designing levels based on Tanya's drafts, and we used the level builder to test them.
Test playing the prototype in the level builder allowed us to see immediately when there was not enough clearance to make a jump, when a level was too short, or when a room needed to be expanded. This allowed us to determine if we needed to make changes early in the process prior to bringing in 3D assets. By speeding up the design iteration time, the level builder made the task of grayboxing much easier. The level builder also came into play a lot during the development process. Partway through, Peter made a script to export the 2D layouts from the level builder as 3D geometry, and we used those as the basis for the background art. Made in August of 2019, our first revised build after the demo was essentially an outline of the full game. The gameplay was rudimentary, there was no sound, and the levels were represented by gray boxes. The advantage of this gray box build was that it helped me to quickly determine if the space was too big or too small. In the first round of reviewing the levels, we knew immediately that the levels were too cramped and needed to be expanded. That review session also gave me a sense of which areas were confusing to navigate or needed to have more interactive elements.
The Graybox build was the first real test of the changes we'd made since the demo, our new designs, new procedures, and new tools. While the game itself was still incomplete, this first build reassured us that our back to the drawing board approach would pay off. At the same time, the build allowed us to identify a lot of issues with the game. The biggest one was inconsistent difficulty. The first level was too hard, the later levels too easy. The first level was copied very closely from the demo, and it inherited a bunch of baggage thereby. It ended up confusing and frustrating, very much not what we wanted to start the game with. Later levels featured more open, expansive designs enabled by our new tools. These had different problems, specifically caused by a lack of friction. Past the first level, the player could stroll through the game with very little in the way of challenge or enjoyment. While we knew a lot of the game's appeal would come when we added the background art and narrative elements, we also wanted the primary gameplay to be engaging. There was a lot of hard work ahead of us, but the Grey Box build marked a turning point. After starting over, we'd taken a somewhat tentative approach, but we acquired more confidence when our new ideas withstood the stress test of the build.
That's all for today, but be sure to be back soon. In the next part of the series, we'll discuss adding the meat to our bare bones build.
Be sure to subscribe so you don't miss that video. Thanks for watching.